Okay, good evening, everyone, and yeah, welcome back to the first stream we've had in a while. Going to be doing something a little bit different. So, if you haven't seen the Twitter thread I made earlier about this, uh, I have a project that I'm going to start working on, like a live coding project. I'm starting from scratch. Clearly, you can see the empty environment here. I'm not going to give anything any kind of descriptive name. Basically, the only stuff we're going to see that makes any sense is stuff from the C++ standard libraries. If you think you know what we're making, drop a suggestion in the chat, however you want to do it. I will update the name. I will update the name as long as it's a reasonable suggestion, even if it's not correct. So, let's get into this. I already know there is a function that I'm going to want. So I'm just going to call this file A, because that tells people so much about what we expect to see in this file. Okay, and so prepared for first clue coming up. We are using Dex for this. Okay. So what do I want to be? We might also need to be including do not. How do you just get pair for free these days? I struggle to remember sometimes which things are actually part of the standard anymore. So what we want is a function that is going to return not going to tell anybody anything else about what this is doing. This is going to get so confusing to try and write any sort of code. This is also incorrect. I've just realised already I'm making mistakes. Great start. This is why I'm not allowed to do real work at work anymore. What do you not like about... Oh, yeah. We are also probably going to need to make sure that we've defaulted to using a sensible version of the C++ standard. I know when I started looking at this before I did the updates, it was defaulting to C++ 11, which is definitely not what we want. Let's see if I can remember. We've got no CPP files yet, so we're not going to have the option. Okay, so we have a function that wants to return a deck of pairs given 4 iterators. People can probably start guessing something about what this is already. Okay, so what we want to say here is... We're going to do a thing. Yeah. So just realised the other thing that's missing here. The other thing, of course, is we're definitely not going to be using good practice and doing test-driven development or anything. Because, you know, seeing what tests I write would also start giving some stuff away. Yeah, you have no... Right. I'm going to add a main here just so that I can get it to... I probably want to zoom the text in a bit as well, because nobody's going to be able to read that except for me. Okay, so hopefully now... There we go. Can anybody remind me where the... here we go. Yep, let's use latest. Hey, suddenly optional works. And then we want the same for D does not equal B. Whoops. I guess we're on F here, aren't we? So we want to... No... And this is going to look very, very similar. Except that here we doing that. No, let's try doing a sensible thing. And there's one other key thing that I particularly want in here, which is... what are we up to now? G. I'm also just going to make a note for myself on actually what things I need to call where. Ooh, thinking about it, there is also a third thing that we need to do. Which is... Okay, so we want to go over all of the pairs in J. And then actually use the right is that a method or is that just a member on a pair? Is just a member data, not a member function. Okay. And now I also need to remember how stud optional works. I think it has value. Oops. Okay. So that's all of the main utility things that we need for right now, I think. So let's start actually putting in some of the important stuff that we want. I mean, this is just my force of habit taking over to make sure I know where things live. Okay. So now I need to go back to my reference material for what we're actually building. Okay. probably going to want to include this. We are almost certainly going to want to include that. And we probably want to include that as well. I'm just leaving this in as it's clearly an error type. For now, and this can have a member A. This is where I test myself and see if I can actually remember the signatures for all of the move operators and things. Oh, no, that's not a const. Okay, so we're making this explicitly non-copyable. And to start with, we are going to implement 2 I'm actually just going to forward declare this for later. Fine. Just have an empty type. Just so that we can actually potentially start compiling things in a little bit. Right. So these are sufficiently distinct from the member names, so it's fine. I mean, honestly, just source and header is almost worse than the names that we're currently giving these things. So we want A and B. And I've lost Twitch. Where's my Twitch gone? This actually, I believe, needs some parameters. Ooh, okay. So in fact, we probably don't want this. I don't think. I think we probably want this. This might give more clues. I don't know. And okay, so this takes a parameter. Let's actually, so that I know what type of int we're going to use and it's not going to change on me massively unexpectedly. Okay, and B actually doesn't need any parameters at all. Okay. Okay, so here, this is where I need to actually be very careful about the okay, so we have that map and that map. Stop pinning it. No, I've just realised we actually do want a vector. This is going to get awkward. Okay. So do that with that constraint. So what I actually need is find fact. That's what I want. In a have I got my brackets wrong? No, okay. So that is going to be true if it's the first one. And here we're just going to have an error case. And if all of this is okay, then what we want is that B is going to equal actually, let's do this slightly differently. B is going to equal this case AA. In this case, B is... No, in this case, B is going to equal AA, because this is the case where we could find... and in fact, Trying to write code this way is really difficult, if I'm being brutally honest. I do not recommend trying to do this unless you really hate yourself. B is greater than BA. What don't you not like about that? Oh, because it's not B. C. So, if we found it and B is bigger than CA, that makes more sense. And if B isn't bigger than CA, then we can just use it. Otherwise, B is going to... Okay. What we then need to do, I guess, is do CA equals another type B, which the compiler is not going to like for a moment. And B then equals yeah, that should be AA. Okay. So if we couldn't find it, we make it with that, and that's what our B is. And here, what we say is also yeah, I think I've just realised that B needs to be an optional. In fact. There are better ways of doing this because we're making this optional now purely for the initialization case, I think. Anyway, so if that, then it's D, I think, isn't it? Is that not the correct syntax? Oh no, because it's decided that that's an option. So we have to extract it from the optional. Here, we then want to so B is going to equal actually let's do this a slightly different way that's way more sensible. Fine. What's the easiest way to... I thought pop back on a vector actually returned you what the last thing was. Rather than just removing the thing at the last... Oops. Missed an underscore. Okay. Just for my own ease, since this is the file it's in, I'm actually just going to change all of these. Whoops. Okay. So now, should be able to actually make one of these. Hooray! Something is happening, maybe. Oh, actually, let's also stick in a new text source. If anybody guesses anything, I will stick some text up on the screen as well. If it's not, directly in the code already, so that any notes that we have get kept. Okay, there we go. If anybody has any guesses for what we're actually building, like I say, feel free to drop them in. I can either update names or I can add correct information, at least, to what we know. I turn this into like a whole hangman thing in the end, and so if you make a bad guess... Okay, so and I'm pretty sure everybody can now guess that another type is going to be called C. So here we can now make a C, which takes B. which here is going to be called A, because this isn't complicated in any way. It's just occurred to me I forgot to make my destructor virtual in the other class. We're not planning to override it, I don't think, but, you know. In fact, I can just... I can't spell default. If I could spell default, we could make it default. Okay. Does this thing make sense? Yeah, this actually wants to do logic, I think. Actually, I don't even need to do that. Although what I probably should do is... Okay. Does this need to be copyable or movable or anything of the sort? Honestly, don't know. Probably needs to be movable. That's just somebody else talking to me about C++. Fine. Let's go with the premise that we've gone with before and make it non-copyable but movable. Yeah, actually, we may not want that to be defaulted, but we will see if that's the case when we get there. It may need to be copyable for reasons that I can try and fix later. For now, I'm not going to be worrying too much about a lot of the sort of performance side of things. Yeah, okay. That makes it happier. You see, I agree with it saying that, but we actually do need to do logic on it. And In fact, hang on. This is... How did we call this down here? Yeah, no, never mind. I think all of that is nonsense. Let's go back to that. That's a much more sensible thing to do. Now, I'm actually going to do that. I can't even be bothered to do it that way. Let's just assert that A is less than or equal to A. Where does assert live? I think it actually lives in assert, doesn't it? Okay. So in a debug build, at least, that will explode horribly if you try and get it wrong. Where's our other error case? Because I should probably do the same thing there. Oh, we had a second error case. Where is it? Oh, here. Also, I should actually include assert locally here. Probably doesn't matter because I'm including it through B anyway. Okay. So, in theory, we should now be able to pick some values and do b.a of a value and a value. Let's actually see if this compiles with what we have so far. Hooray! No. No appropriate default constructor is available. And here we find the typically useful place to jump to an error message. Trying to... Which line of our actual code is it trying to build? Okay, it's just trying to build a map of a uint64t to a C. Why is it trying to do a default construction of? Because surely this... Trying to build this line, it should only be doing that in the case where it can find it and it hasn't had to default construct it. Fine. Also, why does this still have a squiggle? It has a very incorrect squiggle. In fact, let's even do this a more sensible way than that. It's very invalid with zeros, but that should at least make the errors go away. Okay. So, we need to have something that's going to allow us to inspect this, I think. We're going to also at some point need to start looking at a whole bunch of extra stuff, but okay. So, does anybody have any ideas for anything we've done so far? Meantime, we're going to need a d.h. It's getting deep now. This wants to include D, and it also wants to include deck. This actually wants to hold a deck of Ds. Whoop. In A.H, isn't it? How far have we got in single letter identifiers in this file? Does this actually even work? The answer, I believe, is no, not the way I want it to. So that's something to think about. But if we only stick to a single C, I think we should be okay. Oh dear, the what we know label is going to be subsumed by Visual Studio. Let's just move it down a little bit. At the moment, we don't know anything. Okay. Stop pinning things. Equals EA. That was not actually intentional. Let's just see if we need an operator for this. No, I don't believe so. I guess actually there is also a third operation that we should add to B. Yeah, I think there's going to be some problems there. I might need to tidy up how we refer to things later. But, you know, problems that can be solved. Okay, so what does this want to do? This wants to clear basically everything. It's still called clear on a vector. Okay, so for clarity, to be valid, anything we do has to start with b.a and has to end with b.c, and we can do whatever we like in between, within reason. So this needs an operation. Okay, what this operation needs to do How's that for a line of code? Anybody understand it at all? Okay. It's kind of like an operator this way. And then in D, we can have an operation B. And it can do for everything in there. It's going to do A dot A. Okay, fine. I'll get to actually working out how that bit works later. Don't need to worry too much about it, I don't think. But what we do need to do is make sure that ooh, okay. Could we do it that way? If we this, I don't really want to do that because I want these to be default constructor. Trying to work out if there was a better way than having this call to M here, which we kind of want. But what we want is we want this call to M to reset to 0 for every C. But in a nice sort of transparent way. Okay, for now we can kind of leave it. I've also actually missed an important operation. So actually, this should be B. There is a more important operation. No, never mind, because now I'm thinking of the wrong type. There is another important operation. This should be C, I think is what we're saying. Okay. So this actually wants to set B to A. I might need to query the exact specification here. It's not entirely clear to me what some of this wording actually means. Because it could mean B equals A, or it could mean that there's another variable here that we then need to set to B. for now, I'm going to assume it's this. I'm also going to give it in fact, oops. A is less than B. Wow. What key am I even pressing? I guess that's the obvious answer, isn't it? Okay. That here. That here. We want to also do that here. Okay. Not that we can do anything that would make a call to B do anything just yet. But actually, we can. Because... So what we should be able to do, in fact, is... I've also just realised that actually what this should do is this should return a reference to a C. Reference to a C, it should return that one. And then we want to, if we a.c, we should then be able to a.b. Hooray! Failures. Yeah, that's fine. We can actually get rid of M. We don't use it anymore. But if I now do this, and now we get to watch it all fall over in real time. And watch me actually set up my debugger that I've never set up on this machine, apparently. So A's C has a bunch of things in it. And then if we step, that's interesting. So all of those should now be B. they should not still be A. Interesting. So we watched that change. Why did it not change here? Oh. No, I know exactly why it didn't change there. Because I missed a tricksy character. There we go. Now we've turned all of these into Bs. And then if we call B, hooray, they're all A's. Okay, so that much at least works. I guess technically, actually, because this could return not a thing. So, yeah. Okay. So in fact, actually, that's a very good point. Needs to work that way. For very specific reasons that will make sense. Okay, so now we want to actually just return B. You're right, you did expect a semicolon. So that is something that should make sense, I believe. Okay, so here we're going to call a C. So here, okay, so we've called C. And now our A is this. And if we inspect B, that's problematic. That's also wrong, but that's kind of what I was expecting to happen. Because there is a serious question about lifetimes here. So I suspect this is probably the definitive. Is this the definitive thing? Or is this the definitive? Or is there just a big bucket somewhere? I think if we make that a ref, then, so if we do this, what we actually want to do is C copyable? I can't remember. Okay, so you can copy a C or move a C. So the worst case performance-wise now is that's actually just going to copy into D. I think we can live with that. Yeah, the problem is we need to make sure that regardless of where we look it up, was a also if B equals A, we then need to also do B dot A on it, I think. With B. Oh, this is really challenging trying to write this code. Please, anyone, feel free to pitch in and save me from the the horrendousness of what's going on here. Okay. That's basically the question. So it's LiveCoding, project from scratch. I am obfuscating it as much as possible. If you think you know anything that is going on, drop a suggestion for what it is. If you have a suggestion for naming variables, as long as it's reasonable, I will put it in, regardless of whether it's right or not. If you have a general guess that is correct, I will add it into the what we know panel off on the left of the screen. But for now, the specific thing is in our B class, we have an optional C, a map of ints to Cs, a map of ints to ints, which I've kind of not used yet and should do, and a vector of Cs. But the Cs in here need to all be the same objects, not just the same types. copy that into a C is something, so you initialize it with an int. You can occasionally give it a different int, and it sets this secondary integer value. And it has a deck of things called Ds. In fact, if I quickly take out the bit that's broken here for a moment. So there's not a lot of this has been implemented yet. But I can show you the things that it will... Ooh. What's horrendously broken? Yeah, that's what I thought. We'll come back and fix all that bit in a moment. Basically, yes. So if you rename something and then decide later it was wrong, we can change it. I will probably exercise judgment there, and if it seems to be renaming to something worse, I will try and keep it as it is. I've not necessarily thought all of the edge cases of the rules for this through, but... okay, so here we've created our B, which is the entry point to everything. Yes, we can certainly rename that. Oh hey, apparently my bot is working. Does Visual Studio have a nice refactor button? Ooh, that one. Did I completely miss that? Okay, let's, Oh yeah, thank you. Yeah. Oh, yeah, rename. There we go. That'll do it. Yeah, go for it. And in fact, what I will also do while we're there is rename the header. And we got everything. Excellent. Yeah, okay. So we run what we have at the moment. We create our B. We use the A method, passing it some completely random values that have no popular meanings whatsoever. We call C. What C has done is all of these used to say A, and now they all say B. And then when we call B, they all go back to A. And then everything gets destroyed, and the world ends. Which is not a lot so far, but there's also a bunch of utilities that we are about to start needing. So in B, we have a mess, basically. So there's a vector of the things with decks. there's an optional thing with deck, and then there's these two maps. So one maps just a number to a thing with deck, and one maps a number to a number. And what actually happens is if you call A with some numbers, if you already have B set, then we shunt the value of B into our vector of things with decks and reset B. Yes, it is also move only. It seemed very dangerous to make this a copyable thing. Sure. Yeah, just apply it everywhere. What did I miss? Oh, I missed it here. Yep. So it's got three things, basically. C is probably the easiest one. C just nukes everything. Okay. So what B does is get the thing at the back of the vector. Ooh. I would if I could spell reset. It's challenging. Yeah. So B gets the thing at the back of the vector and stores it in the optional. A will either create a new thing, or if it exists, fiddle around with an existing thing. And in fact, there are other problems with this. Okay. So what did this one also need to do that I just realised? Sometimes I might just stick a comment in as a reminder to myself of the next thing that we need to do. Oh, absolutely, yes. Like I say, my fear is if I put better names in, it kind of starts giving away a little bit what I'm actually trying to make. Which seems to go against the spirit of the thing. If we're looking at the move-only thing with maps, there's an optional thing with deck. There's a map of number to thing with deck, a map of number to number and just a vector of thing with decks. Things with deck? It's nice seeing this with actual words in it. Okay, so in the meantime, everything lives here. Okay, so we say everything lives either here or here. This then should actually be... I mean, fair. Let's do that right and not have to do it all manually. Okay, so yeah, back pops the thing off the back of vector and sticks it in optional. Unless vector is empty, in which case the optional remains empty. Ooh, actually, that's an interesting point. That's possibly not correct. I think, actually, that's where everything should definitely live. So if you can find A in map 1, optional... yes. So map 1 is the definitive living place of all of the things with deck. Because I realised that if you back too far and throw them all on the floor, you actually, I believe... Let me see if the specification actually says anything about it. Okay. I think what I'm intending is correct. I make no apologies for the fact that I like snake case. Um, question is, should this then also be a pointer to it? Yeah, so the A method, for now let's ignore that bit because that's needs some work. So A, if your optional is already set, we add to the back of the vector. So if you call A and then B, they are basically opposites of each other, assuming that call A and then B. Yeah, okay, they're at least close to opposites of each other. So if the optional has a value, we reset it. And, we push its value to the back of vector and reset it. And then we create a new thing with a deck that lives in the owning map with a key of A and a constructor parameter of B. And optional goes to point at that. I think I'm going to come back and probably smart pointerize this ultimately. Which actually, yeah, we now don't need to take the address there. Whoa, that's a weird place to put a star. Yeah, and let's go for it. I mean, I think some of these are going to be incredibly difficult to guess until... Oh, sorry. It's supposed to be maybe add. Some of these are going to be incredibly difficult to guess correctly until we know a little bit more about what else is going on here. I will say there is one colossal hint that I don't want to speak too much about because it makes it way too obvious. It certainly does do some caching. I'm not sure. I'm not sure it's necessarily correct to say it is a cache, but it certainly has a cache. I guess realistically, I should probably just make all of these shared pointers, is the answer. Is it in memory? Sure. Fine. This one is going to be called deck. Okay, I will come back and declare it with no except later. Give me 1 second quickly to fix this bit. Okay. Now we can go have a look at D. So D has an int, and it also has an E, which is just an enum that is currently either A or B. And it has a method that switches the state of its E. So if it is currently EA, it becomes EB, and vice versa. Which is mostly relevant because the thing with the deck so the thing with the deck then has a method here that just goes over every D in its deck and calls A on it. So, in the meantime, I am going to also just come in here and skeleton out some functions. And this is where I now need to briefly remember which way things go. Sometimes I need to Wikipedia. Okay. Oops, that's not open. No worries. Thank you for coming and hanging out so far. Thank you for the follow, Ed Hebby. Oh, and thank you for the follow, Jeffrey Lindsay, as well. Okay, so for this, Which way round should we do this? I'm thinking that one should be first and that one should be second. So we want to assert that int2 is greater than or equal to 2. I thought I recognised your name. Thank you for joining. There may be a subtle reason why I've... Oh, actually, that's a good point. Thank you for reminding me. I should... like, get the logo or something. Can't remember where the logo lives. Curses. For next time, I will remember to ask somebody for where the logo lives, and I can stick the include logo up as well. What I could do is... what's the... That's an important thing for us to know. Yeah, there's definitely a key reason I'm using C++, though, being part of that community. That can go away. Why is my taskbar not going away? Oh well, never mind. There are bigger problems to deal with. We don't need my Twitter up. Okay. So this wants to... this wants to do a deck.begin. Auto... Oh, helps if you put the underscores in the right place. Auto B equals... ooh. Nobody saw that. That equals G of deck. And auto C equals deck.n. Yeah, also feel free to drop any suggestions in if you have suggestions. What things should be called to make sense? Okay, so we want to call... I on A on the iterator. Easy. I think. No. Down here. But I don't necessarily trust... T is D. What's the problem? Okay. So, what this should let's actually separate this out. Ah, no, okay, I know why. Turns out shadowing is a problem, I think. What are you trying to convert to a uint64? Oh. Yeah, okay. Although you really probably... Ah, okay, because, yeah, now it's trying to... Does at return an iterator? I hope at returns an iterator. Oh, also, that was going to go very badly wrong as well. I mean, I guess we could also rename those to be what they clearly are. Oh, yeah, also. Fine. I'm going to rename this one just to avoid the conflict. I can't even read that error. Let's see if the compiler gives a more readable version of it. Yeah, okay. That's just because I've put it in the header file and it doesn't like that very much. Right, back down to just this one error. Wait, oh, no, it's not because of that. It's because I actually did already have a D. Okay, here we go. Yes, it is. It's here. What's that if it's not a member of it? Oh, yeah, because it's a shared pointer. Fine. I wish I would stop accidentally hitting, like, just a random button. Okay, so that should fix that. And now we're down to just this no matching overloaded function. So this is a stud. Not deduce template argument for T. I can tell you what the template argument for T is. No, because G has to return the right thing. Yeah, so you give it a const ref to a deck of T's, and it returns you an iterator into a deck of T's. What is it failing to deduce about that? I'm not sure why it's failing to deduce this. Argument types are deck iterator with D, deck iterator with D, and a deck iterator with D, and a deck iterator with D. That looks like it's pretty deducible. Also, I'm sure I had this function working before when it wasn't written in a ridiculously obfuscated way. Sure, I closed you before. Go away. Probably actually just turn it into silent mode if I can still do. Forever. I'll turn it back on later. Okay, so other than the fact that that can't work it out, I should basically just be able to do that. It'll wrap everything up neat. But that's just because it can't work out what type we're getting back here. Okay. Is it going to get really mad at me if I start removing all the type name bits? Yes. Fine. Okay, let's actually just... Let's be really explicit about this and see if that fixes it for now. just to kind of keep us going. Does that help you at all? No. This is just being given 4 iterators. What does it not like about being given those 4 iterators? Okay. We will work this out later. Get rid of all of the templating. Then we can actually just make this concrete for the time being. And I can, you know... Ooh. What am I even doing? I can try and fix the random templatey shenanigans later. Do you not like about it now? Oh, yes. I don't need to do that, I guess. Is that it? Fine, we'll do it that way. Okay, so it does actually work out the optionals. Fine. Which means this can at least get a little bit tidier. Okay. Right, actually that can just set deck directly. In fact, you can just cheat it the whole way and do deck equals I of AA, like I did originally. Now, there's going to be a certain class of person, I think, that sees this next bit as a very large hint. Yes, now we find out if it worked. So more errors. Wow, that's a lot of errors. Why is it a const iterator? Yeah, I had a feeling you were still going to think you were a const iterator. Is there an easy way of getting this conversion to happen? Because clearly one of these things is believing it's a const iterator when I don't want it to be. And I'm somewhat averse to using const cast if I don't have to. Yeah, see this... Ah, fair point. Yeah, it's probably because the parameters are const deck. Thank you for that. Where is G? G is... yeah, because that one's const as well. Probably. Maybe not. Although, maybe because now it's an R value, the way this is currently written. And 8. What does it now think is multiply defined? I should think this is multiply defined. It's it probably shouldn't be in the header anyway. Oh, no, I know exactly why, because I was using the wrong paste buffer. There we go. That's the problem with using VS Vim, is sometimes you just forget which paste buffer you are actually using. There we go. Now it isn't multiply defined anymore. Okay. So let's see if this behaves the way I actually want it to now. Is that correct? Hang on. Let's make this number smaller. I think I can work it out with 10. Value, raw view, pointer, deck. That is correct. In fact, in theory, if we do that, and I've done this correctly and understood the maths behind it correctly, what we should end up seeing is, okay, so we run that, it does that, we run that, and it goes completely wrong. Damn. Oh no, hang on. Actually, that might be right. Then it's going to be, so it should be 81462. No, okay, that's right. I got my my mental maths on that wrong. Those are not reverse operations of each other. Okay, so those new methods we've added work, which is always good to know. What we should also do is see if the lifetime management stuff we've done works for this as well. Because what we should be able to do, let's set this back to 42. So yeah, if you want to actually start seeing some of what these methods actually end up... Okay, it runs. You got to put breakpoints back in. Okay, so at this point, we have... Yeah, so we've still got our big one, and we've pulled C, so everything's turned into B. Then we maybe add, and now it's got this 10. And if we have a look at B, there's one thing in the vector, and the thing in the vector is, other than being a thing with deck, oh, this is the one I actually wanted. That's why I couldn't find it. Raw view, pointer, deck. That is the correct set of values. Yeah, okay, that doesn't help. So we can now E and E0. And if we do that, we should see we get the behavior we did before, which is correct. Then we back. Vector here is now 0. The owning map is a size of 2, which has 1 and 13, which has the correct stuff. And if we have a look at this deck, it has some stuff in it. There we go. So far, everything is working the way it's intended. This is indeed good news. Okay. So, the next thing to do. Could be some really interesting stuff we can start trying to play around with this later. But for now, let's keep things simple. Yeah, there's a very I can give a hint, which is that one of the data structures we use, the pronunciation is the same as something we would see. Okay, let's give a more useful hint. Okay, let's do this a sensible way. Okay. The reason for that is that actually I thought I was passing it in as a reference, and looking at it, I'm not. I'm passing it in by value. So I was concerned about using accidentally moving one of them. So if we look at what that utility thing actually does, is it's using the second and fourth iterators as endpoints. So I didn't want to, when these two are the same, I didn't want to accidentally move one of the endpoints as we work through it. But yes, you're right. I should be able to just do it this way because of the fact that so the place it's going to get interesting is when we call this particular method. That is... Okay, that's working. So yeah, in theory, you can use the combination of these two to move a card to a very... done it. To move one of the Ds to... pretend you didn't hear that. To move a D to a specific part of the thing with deck. I got briefly carried away there because I find this whole thing quite interesting. Yeah, so if you work out the index of it in binary, I appreciate that, thank you. Curses. Yeah, if you work out the index you want to put the first thing to in binary, you should be able to use those two overloads combined to move the first one to any point in the sequence. Anyway, I was just going to... this is actually a really easy thing to do. There we go. That's a very simple method. Yes, basically. I think that's likely to be the only... Well, it might not be the only place. See, this isn't specifying enough to be entirely useful. So AA is a slight variation on quite a well-known algorithm. I'm honestly not sure what it does. Hang on. I'm now vaguely curious. I'm just going to quickly open up a putty. Because I know it's something I use a lot in Python. And I'm not entirely sure what the behavior is in Python if your sequences are not the same length. So the important distinction that I'm making... actually, that's a very good point. Not only could they be, they absolutely should be. Which would have also solved my previous problem of worrying about accidentally moving one. So yes, the purpose of this is... I mean, effectively, you're looking at two different sequences. Although I don't specify what happens if those sequences overlap either. Which could be an interesting thing to try. And that is absolutely what they are. So let's do it. Okay, I'm actually going to break this up a bit for being able to see the parameters. Wait, range 1n. But yes, certainly this is my take on quite a well-known algorithm operating very specifically on decks. Okay. So in Python, yes, absolutely. If they are the same length, you shouldn't do anything else. And in fact, the quick test in Python shows that the algorithm I'm trying to use here will give you an output that is as long as the shortest input. Given the nature of what we're actually working on here, for me it makes more sense in this case that you might actually deliberately have sequences of different sizes, in which case, once you've paired up what you can, you have the rest unpaired. So that's what these second two loops handle, is each case of either the first sequence is longer or the second sequence is longer. I'm also, while we're here, I'm just going to rename this to out, because it's clearly the output thing. Yes, exactly. In fact, what I haven't done is check to see if this has been added in a newer version of the standard. No, it does not appear to have been added. Good. My Jonathan Bacara map of algorithms is currently in the office, and I don't particularly want to break isolation to get it. So I'm trying to go from memory for a lot of these things. Also, it's worth noting that the algorithm we actually want, this is only the first part of it. The second part is also quite a well-known thing, which takes these pairs and turns them into a single sequence again. So you can kind of see that in the way the output works when we call E here. You have the version of E that doesn't have the parameter. So we start off with a sequence from 1 to 10, and we E, and we end up basically with that sequence interleaved with itself. And the integer parameter does it the other way. Fair enough. If you've not come across it, then you wouldn't know. The thing it's typically known as is a zip. Yeah, for example, if you're using Python, zip is just a built-in that takes two sequences, typically like lists or something. And instead of two lists, you end up with a list of pairs. That's just what happens if you pair up parallel things in the two lists. So yes, this is just a zip algorithm, the only difference being that it handles mismatched lengths in a different way to a traditional zip algorithm. So like I said before, zip will typically truncate to the shortest input range you have. This will actually carry on, but blank out anything that doesn't exist. Which is then where this one comes in and has to handle the fact that you might not have a value there. It is precisely flatten, in fact. So yeah. In fact, since we already know that this is now calling a function midpoint, let's also change this to be something meaningful. So yeah, this E method basically does the same thing regardless of which overload you call. The first one interleaves first half, second half, and the second one interleaves second half, first half. So this is why you end up with some of the slightly odd sequencing. I think if we do this, I think this should put number 1 in position 5 at the end, if I've got these the right way round. I'm now just curious to see if this works, because I've never actually tried it in real life. Wow, actually does work. I mean, the person who invented that knows a lot about this kind of manipulation, so trustworthy source, but... Yeah, okay. So I think then that actually that is... Is that supposed to be completely random? Okay. So I think that's the next thing we implement. Algorithm. I am so incredibly glad that that exists. I wonder if my version of Visual Studio will let me use it. If this works, welcome to C++ 20. No. It's supposed to be in that namespace. Are you telling me that this version of Visual Studio doesn't support Nibloids? It should be, yeah. Yes. I might just need to actually try and get possibly the ranges library. I'm actually assuming that probably takes iterators. So it wants to be if it works the way I expect it to, that should work. We'll find out if I ever actually set it up to use it. It's using C++ latest. Don't know if there's another. One thing I actually haven't done, which I liked. Ooh, it now doesn't build. That's fair. In fact, that's going to get misleading because that's not going to be the case when this is done. That should at least clear that bit up. There we go. Because then once this is there and we're actually using A and B, they are definitely always used. What was the other thing I wanted to actually try in? I wanted to a.value. Now I need to actually also work out its f. Because I also want to make sure that everything works with the state correctly. So what should happen here is we look at the deck. So this is a fresh thing that just goes from 1 to 10. And okay, so we've flipped the A to the B, but only on that one, which is correct. And then we move it through, and it's all good. One other thing that I should probably check for something we've already implemented. Oh, that's not going to be problematic at all, is it? Okay, so this is not correct. Okay, so this wants to take I'm pretty sure we can do this with just things in the standard library still. Okay, so in fact, what we do is this, I think. Okay, now let's see if this works correctly. Actually, what I probably should have done was do that afterwards. So we know that this was at least working correctly down to here. At this point, yeah, this is the big one. Hooray! It fell over horribly. Yaha! It's alright, we know exactly why this is. That's because we didn't actually set up that map. It's called map 2. At least it proves that the assert works. I'm not convinced that's entirely correct. And that's definitely not correct. This should be the smaller one in, yeah, probably that order. Oh, whoops. No, that's because I am a Muppet. That's the one that was supposed to get that. Now back to what it was before. And now let's have a quick check so I can see what's in here. So 1 is 4, 6, 2, 3, 10, 1, etc. 6, 2, 3, 10. Now it's working correctly. And now also it should be, yeah, there we go. Now that's actually doing the thing that the specification says it should be doing. Okay, I now also want another one of these. Oh, do I want that there, though? Possibly. We might use this to tighten up some stuff later and prevent people from doing things they shouldn't be doing. Yeah. Yep, afraid so. That was as I suddenly remembered that actually there's gonna be there's gonna be some more stuff. In fact, we might end up needing to extend thing with deck so that we can arbitrarily add and remove objects of type D. Because there is a point where A, we're going to need to be able to do that, and if you add anything of type D and then call B on the thing with deck, anything outside of the original deck this had need to migrate to a special holding area here. But for now, we're just worried about the fact that we need to know if this has anything in it. And in fact, it's going to be a while before we actually really get on to what this one does. But the fact that this is here and has no value is going to become progressively more important. Oh, okay. I think for tonight I'm going to implement one more thing. But I'm going to implement one more thing that is going to be potentially interesting. This is definitely in the wrong place, though. This should be here. And let's follow our naming convention. So these are actually just going to start with 0. I figured it was probably going to be fairly clear what this thing did. Yes. Okay. So VoIF. Everybody loves a good VoIF type. So what we want is dot begin plus int 3. Then thing is, I now want to do like a double transform on this. And I'm not sure what the best way to do it is. See, some of these things would be really easy for me to do in Python, I think. I'm pretty sure you could do this with a list comprehension, although it might be ugly. So what we want to do here Oh, absolutely, yeah. I'm just trying to think about how to do it at all. So, okay. So first of all, there has to be like a basic reverse algorithm. Let's start there. There we go. We've still got algorithm included, haven't we? Yeah. Excellent. And then we Whoa, where did I put brackets on that? And then we want to do begin equals deck.begin again. Okay. Again, I feel like there's quite a lot of stuff here that if you start knowing anything we're doing, a lot of this probably starts to become quite obvious. Which will be interesting, I think. Okay. Is it even going to build? Yes. Excellent. This is a good start. Okay, so we set int 3. Int 3 is now 3. Hey, it worked. Okay, there has to be something in here. I've changed my mind. I'm going to implement one more thing. And I'm going to implement one more thing because then I can write something and see if it behaves precisely the way I want it to. In fact, greater than or equal to 2. And okay, so what this wants to do is take want to take that and we want to put it somewhere else. Okay, so I think what we can do is stud move. +1. Stud move second last, I think. Oops. So, yeah. So anybody who knows me and can work out what I'm doing, it is a little bit. What I'm actually going to do here, here's a slight clue for you. The thing that I'm going to write as a test for this last function I've done is something I am able to physically do in real life. It's one of the few things I'm actually capable of doing in a way that that can trick a few people who don't know what's actually going on. Yeah, okay. What's the one that does that? F. Oops. A dot value. What's the one that we've just done that does the I? Another R. And then I think we're actually going to need some functions that I've not implemented yet to do the rest of this. What went wrong? Oh, because it's no longer called int2. Okay. So that's going to reverse and flip the top three. And then flip that one back. And then fall over because of a bug. Is that supposed to be inclusive? No. Okay. So that's a problem with my move semantics. But yes, I guess now I've added that hint, I should probably add that it has a mapping to real life. But yeah, also I've now been doing this for over 3 hours and I'm really starting to get tired. So yeah, I'm going to call it there for tonight. It's been a lot of fun getting back into streaming and also engineering of any kind. It's interesting seeing where this is going. It's definitely going somewhere that's starting to get useful. I think I'm going to need to put some effort into useful clues I can give for next time, I think. That don't give too much away, but maybe help out a bit. But yeah, we will see how it goes. I will be back on Monday. We are now back in our usual stream schedule. So yeah, thank you very much for joining me. It has been a lot of fun, and please feel free to give me feedback here if you are in my Discord or the Include CPP Discord, which you can find on the website if you're not there already. Or on my Twitter. Feel free to give me any feedback you like, and I can see about making it better. Until then, I'm glad it's at least been interesting, and yeah, I hope to catch you next time. Bye for now.